All right, so let's get our slide deck up here. And let's progress to the first slide. All right, so I'm Kelsey, as said before. I'm actually a developer advocate, and I actually write a lot of code here at CoreOS. So currently I'm hacking on Rocket, and I'm a core contributor to the Kubernetes project, which we may touch on a little bit in this demo. So next slide. So what I want to do is basically talk about the big picture when it comes to CoreOS. So when you think about CoreOS, it's not just a product. We kind of like to think of CoreOS as this idea that we can turn the way people manage servers into a more efficient process. You know, kind of the efficiency that you find in a large-scale warehouse. So what we want to do is take your servers and automate the updates and provide all the tools you need to host your applications as containers. We think containers are the right abstraction for managing your applications to get away from kind of manual script automation process of putting bits on disk. And if all this works and all the components that CoreOS provides, you should end up with an infrastructure that's highly distributed and fully efficient, kind of like the modern warehouse that we see today. Next slide. And to give people a good overview of what CoreOS is, CoreOS, in our opinion, is a container-optimized operating system. So what does that mean? On CoreOS, you won't find a traditional package manager, so there's no yum or apt-get. Those are traditional package managers that you would find on most Linux distros that are out today. What CoreOS does is it shuns those type of ways of deploying applications in favor of containers. And what we do is we have a minimal OS that's about, I don't know, about 100 megs in size, uses about 60 megs of RAM on the host OS, and we leave all those resources there for your containers. CoreOS starts off as a read-only file system, and what that means is we do everything possible to make these hosts as secure as possible. And the whole goal here is to give you the right building block for higher order systems. You know, there's tools like Kubernetes and Mesos that normally sit on top of CoreOS to provide higher level orchestration. But CoreOS at its foundation is just highly optimized for deploying and managing containers. And on every CoreOS host by default, you'll also find a tool called etcd. So what etcd provides is a distributed configuration and lock service. What this does for us is, since CoreOS provides automatic updates, the machines need a way of coordinating their reboot process. And what they can do is use etcd as a lock service to ensure that the cluster doesn't go down all at the same time. And etcd is also available for your containers to share configuration between the containers. Next slide. And the next question that comes up is, why another OS? So why not strip down one of the existing Red Hat or Debian flavors? The main reason is we saw the need for an OS that doesn't have, you know, any contract with the user. And what we mean by that is there's no Python, there's no Java, there's nothing that your container or application should depend on. So what this gives us the ability to do is update the operating system in the background, very analogous to the way your web browser updates itself automatically. And our focus was on containers and building the missing tools. So once you move into the distributed method of computing, especially based on containers, you're going to need a few tools. So some of the tools that we've written are etcd, which provides that distributed configuration and lock system. We also built a tool called Flannel, which provides an overlay network to allow your containers to talk to each other even across hosts. Now, a system like the one that we provide sets the foundation for automatic updates, and we'll take a small walkthrough and see what that looks like. And the whole goal of all of this, and all the components that we build and support, is to make computing, utility computing, mainstream. You know, we want to have software be able to ship as easily as it does for like the mobile platform. If you look at the iOS, you see how easy it is to install software without having to log on to the device. And we want to make that possible for servers as well. Next slide. One important thing to note when CoreOS talks about containers is the difference between an application container and a system container. Now, an application container really has a single role or responsibility. So we're not really limiting things here to a single daemon per se. You know, you may have an application that requires an Apache web server, a Ruby interpreter, and maybe some other application-specific, you know, web server to process your traffic. The container is just an illogical encapsulation of all the bits that it takes to run your application. Now, this is a stark contrast from a system container. A system container usually has a full operating system with the ability to log in, normally via SSH, and normally a system container will provide its own init and boot like a normal machine. Now, the things that are the same between an application container and a system container is that they share the kernel of the underlying system. So they both lead to efficiencies, but one thing that we like to do with CoreOS is focus on the application container. So we want these containers to be as small as possible. So if you have a system container, you'll often see those in the size of 200, maybe even to a gig in size, whereas application containers really are focused on the application and only the necessary dependencies and shared libraries to produce that app. So a lot of times you'll see an application container weigh in around, you know, 8 to 20 megs in size. And that's kind of what we mean by an application container. And next slide. So once you have that in mind about, you know, building these application containers, you want these application containers to be optimized just the same way we optimize CoreOS. No unnecessary daemons running inside of your containers, only the dependencies that your application requires. And you also should know your dependencies, right? We talked a little bit about file size. If you don't know your dependencies, you'll end up building containers that are about a gig in size because you're bringing in the whole operating system when you only need about 1/10 of the files that are found in typical containers that are built when people don't know their dependencies. And then what you want to do is limit host interaction. So one of the efficiencies that comes into play when you're using CoreOS with containers specifically is the ability to move those containers anywhere. So if you're hosting CoreOS on bare metal servers or you plan to move to the cloud, if you don't depend too much on the host state, mainly the host name or specific mount points, your containers remain portable. And that's kind of what you want when you're building application containers. And the next thing that you want to do is when you're optimizing application containers, and we'll see later on in the demo, is that you want to test your application containers with resource limits. So the key to running containers efficiently, especially in production, is when you're deploying your containers, most of the tools that give you the ability to deploy a container allow you to specify resource limits. Now, these resource limits are provided by the kernel in the form of C groups, and the main resource limits that most people are interested in are memory and CPU, and in some cases, disk I/O. Now, the kernel will provide all the interfaces you need to do this, and tools that run on top of CoreOS, mainly Docker, and things like Kubernetes also expose and highlight those resource limitations. Now, this is a change for many people. Most people are used to deploying an application one-to-one with a virtual machine, and therefore, the application consumes all the memory and all the CPU. Now, your application may behave different when put in a more restrictive environment. So the container also provides these restrictions. So it's important to test your applications with the resource limits in place that you would see in production to prevent any surprises. So next slide. And really quick, for those of you that are new to CoreOS, just kicking the tires, I want to provide a really quick walkthrough on what it looks like to have a CoreOS system and its full life cycle. Next slide. So CoreOS, when it starts out, we have the base operating system installed to partition A. So you may be starting out with CoreOS, and we do our versioning based on the date of release, kind of the epoch of the company being started. So if you look at that, what we do is we have a rolling release. So CoreOS mainly targets keeping your latest Docker version, the latest kernel, the latest stable system D, and we try to make sure that those things upgrade seamlessly to your system. And the way we do this is we take a page out of the kind of the web browser's book or even networking gear where you don't want to log into the system to have to apply updates. And to keep things secure, we built a system that leverages many of our tools, including etcd, to automatically update things to a separate partition. So partition B gets an update, and it downloads in an atomic way, which gives us the ability to roll back in case there's any issues. But we can do these updates without disrupting the current OS. Once the OS is done downloading, we provide all the tools to have their servers in a cluster, whether you have 10 servers or 1,000, that these servers can coordinate rebooting and applying those updates by themselves. It is worthy to note that you can actually turn off automatic updates if you would like to have a little bit more control over when your servers actually apply the update. So you do have control there. Next slide. And once you get up and running with containers, and before you add any additional tools to the mix, you end up with a bunch of hosts that are primed for running containers. So here's what a bunch of CoreOS systems look like before we start adding things like etcd, things like any orchestration tool. And next slide. And what most people end up with is a system that's ready to schedule your containers. Now, this is perfect for people who like to roll their own solutions. So if you like to build your own in-house orchestration tool, or maybe have your own in-house scheduler, CoreOS provides everything you need to start scheduling containers to those CoreOS hosts out of the box. You can enable the Docker Remote API and do it that way. You do have SSH access to the CoreOS host, so you're free to run more traditional like configuration management tools, Puppet or Chef, and have those manage your containers as well. And you can leverage things like etcd to kind of glue those systems together to form a logical cluster. Next slide. So a lot of people new to containers kind of want to know like what the trends are in container usage. So one thing that we saw is that a lot of people have started using containers in the lower environments, which is a great way to ramp up to container usage in production. And one problem that containers have solved is the ability to build full replications of your production environment. So since you don't need a virtual machine to represent each of your applications, including your database, you can use containers to basically replicate a full production deployment, maybe even on a single system. Next slide. And we're also seeing changes in the target users. So, in the beginning, I think it was heavily, pushed towards developers for an easy development environment to produce applications with all of their dependencies. And the next step that we saw from there was in the QA environment. So many of the automated CA tools or CI tools have ability to support containers in some capacity. And the key there is to use containers to provide a consistent build environment for building your applications, and also providing any components needed to do deeper integration testing. So these components would be database servers, things like Memcache. A lot of times you want to have all of those things in place in a clean state to do complete testing. And now we're starting to see a lot more things towards sysadmin. So you're starting to see tools like Kubernetes and Mesos provide tooling that allows containers to be managed in a larger scale, right? Providing the API that sits on top of all of this to give you kind of a better way to do operational things with your containers. And now we're starting to see containers being adopted in the end-to-end pipeline. So if you have a CI system, you can imagine a workflow where code gets checked in, run through CI, and a container pops out. And that container gets stored in a registry, and that registry can be used to back many of the deployment tools that will then push containers to the end systems. Next slide. And before we jump into the demo, we're going to talk a little bit about container performance. And one of the benefits of containers for a lot of people that are used to partitioning their applications based on VMs is that containers provide a way to save resources, and they have very little overhead. Mainly, you're paying the cost of the kernel accounting to enforce some of those limitations. And you get some of the main drivers of virtualization for a lot of people you get this namespacing concept. So you get the namespacing in the form of a unique IP address for each container, and you also get the ability to have a file system to have your own dependencies separated from the others. And also, you can actually increase the density per server. You know, in a typical deployment of CoreOS, depending on the application memory requirements, you can see hundreds of containers per host. So if you're on a cloud platform, the idea there is to move from smaller cloud instances to slightly larger instances to increase the density of your application and to keep the HA that you're using today. And if you think about it, an application container is only going to use the memory required by the application, very similar to a normal Linux process, plus a little bit of kernel accounting overhead. So if you compare that to a VM, which usually these days an operating system requires at least 512 to boot these days, you have to pay that cost plus your application. Next slide. And finally, I want to touch a little bit on the future of containers. So we've talked about the low-level primitives that CoreOS provides for you to construct larger tools, and we're seeing these larger tools in the form of cluster managers and resource schedulers. Two of the most popular tools today are Kubernetes and Mesos. And we're also starting to see specifications around application containers, like really defining what it means to be an application container. And next, we're seeing system containers will probably get a lot more usage. It's already being used heavily in some of the web hosting segments today, where the security of containers is starting to improve quite a bit, where multi-tenancy is becoming a thing that will be very commonplace, even with containers where we see it with VMs today. And next slide. And I'm going to end off by looking at what one of these systems looks like once you have all the pieces in place. You know, that black box in the middle kind of represents these cluster managers, and CoreOS provides a cluster manager out of the box called Fleet. And we keep the door open for things like Kubernetes and Mesos to sit on top and provide the functions that live in that black box. So with that overview, I'm going to turn it over to Matt so we can get into some details on monitoring the metrics and performance of those containers and hosts running CoreOS.
Great, thanks. So my name is Matt Williams, and again, I'm the evangelist over here at DataDog. And so you've just seen, what Docker is and why it's powerful. And at this point, you probably want to know how to manage it. What do you need to look for, and how are you going to keep everything in top shape? And that's what I'm going to talk about. So managing a container isn't all that much different than managing a traditional EC2 instance or hardware box, and many of the metrics are the same as well. We have a solution that you can use to monitor containers, but looking at the list of available metrics can be a bit daunting. So we've whittled that down to maybe the key 11 or so metrics that you should try to keep an eye on. Now, obviously, this depends on the workload, and your application might have other metrics that you need to keep an eye on, but this is at least a good place to start from. So those metrics really break down into four major buckets. Memory, there's CPU, there's I/O, and of course there's network. Now, for memory, we suggest keeping an eye on these four things. There's pager fault, or page faults, major page faults, and minor ones, and basically to make sure everyone's on the same page. A page fault occurs when a piece of software requests a page that's not in physical memory and hasn't been loaded yet. It's pretty common when there's a context switch, but a major fault involves a lot more swapping of memory pages and is a little bit more expensive. So definitely keep an eye on that stuff. Resident set size is basically the amount of memory that's resident, and swap is the amount of swap space being consumed. And so those are definitely good things to keep an eye on. CPU, well, there's two main metrics there. There's user and system. User, of course, being the time your processor is being running your own programs codes, and system CPU, basically looking at the kernel. Definitely keeping an eye on those types of things. Block I/O. Block I/O deals with reading and writing values into data storage. I/O service bytes is basically a number of bytes transferred back and forth, and it's not necessarily a good or bad thing, but it's definitely something to keep an eye on. It will, depending on the application, a lot of service bytes might be good, might be bad. Who knows? I/O queued is definitely something you should keep an eye on, because basically I/O queued is operations that are queued up that can't be dealt with because there's some sort of block, some sort of bottleneck. And then finally, network. Always a good idea to keep an eye on errors, dropped packets, bytes for both transmit and receive. So all of these things, they aren't necessarily a good or bad thing. They're just things you need to keep an eye on and take in the context of your application and whether those are good or bad in your application. So those are some basic metrics, and there's actually others that you might be using. Again, there might be the more application-specific metrics that you're going to monitor. But monitoring one container, it's easy. It's like monitoring an instance or monitoring a physical box. But things get a lot more difficult as the number of containers start to grow, and they're going to grow. So how complicated is it going to get? Well, let's take a look at, figure out a number for average number of containers per instance. Now, we have lots of customers that are monitoring their Docker or container, infrastructure, and we see a large variance in number of containers per instance. We definitely see some people using just 2 or 3. We see some people using hundreds of containers per instance, but on the average, it's about 5 or so. But as that number increases, as more people put more and more containers, everything gets more difficult. Provisioning, configuration, orchestration, and of course, monitoring. Just making sure all those containers are running properly and keeping an eye on everything. So let's basically add up the numbers. If we're looking at just one instance, then with one container and one app, you're already at a little bit over 200 metrics, because there's going to be probably about 10 CloudWatch metrics, maybe 100 metrics for the operating system, maybe another 50 metrics for the container, of which you might only be focusing on those 11 that I talked about. But then there's also 50 or maybe more, or hundreds for your whatever application that you're working with. So if we have 5 containers per instance and you have 100 instances, well, you might be dealing with 500 containers or maybe even a lot more. And one instance with 5 containers, well, that already means well over 400 metrics per instance. If we add up all the numbers from the last few slides, then we can see that 100 instances is about 41,000 metrics that you're having to deal with. Now, of course, your goal is to try to find the anomalies in these metrics. And when looking at 41,000 metrics, finding those anomalies is kind of tough. To make things a little bit more difficult, there's the velocity of everything. If containers lived as long as your instances, then it might be possible to manage it using traditional monitoring tools. But they don't. These things last a lot less. It's so easy to spin these things up and then destroy them that you can very easily, and the system can automatically take over the instantiating dozens of these containers. And so as the need builds, the containers multiply, but then they go away just as easily. So you might have measured lifetimes of instances in months or longer, but nowadays you can measure the life of a container in maybe minutes or maybe even less. So how do you deal with this complexity? Well, the secret, we think, is that it comes down to layers and tags. Now, layers and tags will allow you to slice and dice your information to gain access to what you need while staying fluid enough to deal with all the different things, number of containers, and complete lack of consistent machine names. So you want to monitor everything, and you want every layer to be covered. And you've got some current tools that may already provide some of this stuff. CloudWatch can look at the hypervisor, and it's got some visibility up into the OS and maybe into the containers. And your application performance monitoring system, covers the top of the apps, and it may extend down a little bit. But then you should also, have something that covers everything in the middle. And well, what's in the middle? Well, if we're, the infrastructure might be file system, it might be the Docker memory, the Docker CPU, DB queries, web requests, and of course CloudWatch is looking at the CPU and net and I/O of the hypervisor of the base machine, and the APM is looking at app throughput and all that kind of stuff. And so you've got all these layers, and you want to be able to access all the metrics from all those layers. You want to look at CloudWatch and OS metrics and Docker metrics, app metrics. You want to see all that stuff in one place. And of course, you also want a shared timeline. If you don't have access to all this stuff all in one place, then it becomes really difficult to answer some of those really basic questions. You see one instance that is totally maxed out. Well, is that good or bad? Is that a sign of your applications are fully utilizing the resources they have? And maybe if you only have something that looks at the top layer, and one of those is maxed out, is it a problem in the application, or is it a problem down lower in the stack? You might have tools that cover both of those sides, but if those tools don't talk to each other, or those tools don't allow you to see all the information in one place, it can become really difficult to manage. So layers is one piece, but tags is another. So you're probably aware of tags. Hopefully a lot of you have heard of tags or are using tags. You could think of tags in AWS. You can create tags for any of your instances. In fact, one of the main tags that everybody uses is name. If you want to change a name, you have to go and then change the name tag. Tags have also been part of Windows for a long time, and also on the Mac. And they give you an additional way to find documents from all around your machine that are related to each other. So tags, with regard to metrics, serve that kind of the same purpose, allowing you to create queries that are really, really flexible. So tags allow you to go from imperative to more declarative and create queries that allow you to find the metrics based on these queries. And queries can be really, really flexible, and allow you to aggregate so much data in a really, really easy way. So let's take a look at what we could do with tags and queries. So here's a query that you might create. You want to figure out what's going on with all of your containers that are running the image web, and you want to look at the region US West 2 across all availability zones, and you want to make sure that resident set size is less than a gigabyte on a C3XL. Okay, so here I've kind of popped out the tags, or what could be the tags. So we're monitoring all Docker instances running the image web. Web would be one of those tags, or image web. And then region, US West 2 versus US West 1 or US East 1, across all availability zones, like US West 2B or 2A. And then instance size, C3XL. So all those are tags, and then figure out, well, let's make sure resident set size is below a gig, or just show me a graph of resident set size across all of my instances, or all of my containers. But then, once I've got this very simple query and set of tags, I can change it. So continue looking at the image web and US West 2 across all availability zones and C3XL, but I want to see ones that use 1.5 times the average of resident set size. So it becomes, just really amazingly easy. Once I've created this query that uses these tags, then it doesn't really matter how many machines I have. It doesn't really matter what those machine names are. It doesn't really matter which region they're in, because I can very quickly change my query from US West 2 to US East 1, or from image web to image, I don't know, Nginx, or sorry, image web to maybe image Redis. So makes these queries are incredibly easy to find just the data that you care about. And so now I want to take a look at some real dashboards. And these are dashboards in the DataDog product. And what we're looking at is basically a test environment that I've created that is a bunch of Redis machines, a bunch of separate Redis instances on AWS. And each one, I've got a few in US West 2, and I've got a few in US West 1, and I've got a few in those two places. I've got a couple of different instance sizes, but then I've got them as separate instances, but I've also got them as separate Docker containers. And we'll be able to take a look at some different dashboards that slice and dice that information in different ways. So let's see, close off that presentation and switch over to, okay, looks like I'm seeing my dashboard. Excellent. And looks like here, move this thing out of the way. Here I'm looking at one of the dashboards that, with our dashboards, anybody can go in and either take some of the sample dashboards that we've got and customize them, or create brand new ones. So this is a brand new one that one of my colleagues built. And I can very quickly see that I've got, in this case, I'm looking at 4 containers across 36 EC2 instances that are currently running right now. Although it looks like in the past, I've had quite a few others running, up to about 15 a while back, back at 1 o'clock earlier today. And I can get different types of statistics depending on the layer that I'm looking at. So here I'm looking at CPU utilization that's coming from CloudWatch. Here I'm looking at utilization via the OS. And here I'm looking at user CPU via Docker. And so I'm able to get, slice and dice this information in different ways to look at, well, what's the way I care about right now? And right now I'm just looking at CPU utilization, but I could be looking at a variety of metrics all in the same kind of dashboard. Let's go up and switch dashboards to another layers one. Here I'm looking at, again, slicing and dicing. I'm looking at, on US West 2A, let me look at utilization of all my T2 medium instances, and then also let me look at all my M3 mediums. So I'm able to very quickly and easily create these queries that, in fact, let's take a look at one of them. I'm going to edit this one. And it looks like this is looking at AWS EC2 CPU utilization on instance type T2 medium, and show it by host. And so you can see the different hosts that are basically these different lines are different hosts. Close out of that and close my editor. Down below, I'm looking at the Docker metrics. So looking at Docker by M3 medium instances and C3 large instances. Again, pulling the CPU utilization from Docker. Let's go to the next one. One last one I'm going to take a look at, and this is looking at one particular container. Show me all the CPU utilization across all my different containers that have the same, that are using the same image. Okay, so here's one of our standard dashboards that we provide as soon as you use the product, and I can see very interesting information about how I'm using Docker. And some of these are those metrics that I talked about. Some of these are other metrics that we've seen a lot of our customers are using as well. So I can see very quickly I've been using about 45 instances. Oh, sorry, this is specifically about instances, not necessarily about Docker, although I can see that two of my Docker instances have been the top users in the last day. Let's go to something a little bit more Docker specific. Okay, so here's one that's kind of interesting. I've got the same environment, some Redis boxes that are running either as EC2 instances. Hold on, I'm about to lose power. Okay. So I've got Redis running as an EC2 instance. I've also got Redis running as a Docker container. And I'm actually going to swap out to a DOS prompt. Oh, sorry. Did I just say DOS prompt? A terminal, terminal window. And I'm just going to start off Redis benchmark. So here I'm using Docker, so I'm going to use a Docker exec. I'll start that up. Switch over to this one. This is a standard EC2 instance, so I'm going to start that same benchmark. I'll do the same one over here, and same one here. And that's just going to give me some information to look at on my dashboard. And I'll come back to this in just a second. Let's switch over to one other. It's interesting. Again, all of these dashboards are basically looking at different ways of slicing and dicing all the same information to be able to give you quick access to just the information you care about when you care about it. So here I'm looking at connections, and I see this connections number all of a sudden starting to go up, depending on whether I'm using. So I've got two types of information showing: EC2-based Redis instances, or EC2 instances, as well as Docker containers that are running Redis, going through that benchmark. Let's just switch back to this one now that we've got some data coming in. And I can start to see that information in a different way. So this was just a quick look at some of the different ways you can look at information, some of the different ways that you can work with this information. Let's just, one more thing. Take a look at the configuration for this. It's just looking at CPU user and CPU system for all items that are running Docker. Basically, I have a custom tag that I created that says this is a Docker role. Okay, and with that, I'm going to open it back up to questions. I think we've got a bunch of questions that have come in. And yeah, I'll hand it off.
Okay. Hey, Matt, that was a great job, and that demo was fantastic. Thank you so much for showing the audience that. You're right. We have a ton of questions here, and thank goodness we've got about 15 minutes. We'll try to hit as many as we can. If we don't get to every question, those that are not answered online, we will answer them offline, but we'll get back to you with